I think I understand the concept of the transpiler. I guess it looks really useful for the developer. I'm trying to think about how I can use this transpiler concept for my research. Let me think about it.
Let,
Um,
let
Trey,
me give you one more example here um,
yeah, perfect.
that might help. So yeah, I guess when we talk about kind of edge cases for the transpiler, um, the example here that we have is I have an application that's ThinkComposer. It's a like a mind mapping software. It's an open source solution. Um, and what I've done is this software allows you to define a series of concepts and relationships, and you can kind of drag and drop different concepts together and uh, really map out your thoughts really. So for example, if I say that I have a MakerBot machine, uh, really picking on MakerBot today, and I say that I have a tool head component, but I also have a controller component, it makes it really easy to get my thoughts kind of on digital paper here.
mhm.
Uh, I understand the model well enough to say that I want to track temperature on the tool head, and I want to track not a sample, but the availability and the execution state. Now, where the transpiler fits into this is I've defined these concepts through this software. But what I really want to do after I've defined these is I want to have some hard set uh, synergy with the MTConnect standard. So what I've done here is this software allows me to define these custom fields. And so I've said, okay, I'm going to utilize the transpiler to produce all these drop-down lists. I don't want to have to maintain these lists by hand. So I can say, this is an event. This is a sample. This is temperature. The units should be Celsius. Again, that's from the transpiler. And then I also have the type definition. In this case, I'm looking for temperature. So I can go through the full list of all of the samples defined
I
in the
see.
standard.
Mhm.
So instead of me maintaining this list in this software, what I did is I used the transpiler to generate the list for me. And I created just a CSV file to create that list. Now, as it relates to maybe AI research, perhaps you want to use the transpiler to define a rigid class structure around the types of data that you want to serve as the constraints for your model, right?
Yeah.
Um, you can make sure that your data model that goes into your machine learning model
Mhm.
follows the standard because you're using a transpiler to create that structure.
Mhm.
Um, and then kind of another idea with the transpiler is that if we continue to update these libraries like the C# library or the adapter SDK, if you go to update your NuGet package and you run the transpiler again, and then if let's say you have interfaces that are automatically generated that you then use in your model. If the underlying standard changes, let's say they add properties or they deprecate properties, well then ideally your transpiler will reflect those changes and say, these properties are obsolete. They're no longer necessary, or you haven't added them yet to your code base.
I see.
Trey, can you build that out a little bit more, this MakerBot, just with some other data items and maybe components, and then show how you could, from here with ThinkComposer, it'll generate
Yeah.
the device file for you?
Mhm.
Because I think
Yeah.
this is immediately applicable. I mean, for some of the stuff you're doing, and so I know you're dealing with like what a plasma cutter and some sort of
Right.
press.
Right.
You know,
So
being able
Yeah.
to visually drop components into a device, you know, that represent that machine, and then put the data items or the data items into the components, relative components, and then click a button to generate the device XML in like a visual, you know, from a visual form of the device, maybe. At least simplify some of what you're doing when you're running into machines.
Right. Yeah, so I was curious whether I can generate the device XML from this ThinkComposer.
So Trais is currently linking, you know, the MakerBot device to the tool head, which the tool head he defined as a component, and then he linked the MakerBot device to the controller, which he defined as a component. And then I don't know if there's axes potentially you could add in there, X,
Right.
Y, Z axis.
You want position or?
Yeah, and you could put position. But well, I would make those axes. Well, do it however you.
Yeah, I can do it. So I guess path position actual.
Yep.
All right, so I mean, a lot of this is kind of a showcase of ThinkComposer. So if I have like an axis component that contains all the axes, that's kind of the typical approach. I guess I only care about X and Y because Z doesn't, I don't know, maybe, well, let's just do Z2. It's position actual. I mean, yeah, so ThinkComposer is just an example of like tools that you can use to, you know, lay out, you know, what it is you're thinking about, right? Really, these concepts can be applied to any other kind of software tool. You can generate a transpiler to supply that tool with the necessary information. I guess ThinkComposer is a little bit unique in comparison to other systems that I've seen, in that it allows me to define custom languages, is what they call it. So there's external languages. What I've done here is I have several custom languages. One of them is device response document. So what this allows me to do is I can look at the concept that I defined here for device. I can look at output templates, and I can select the language that I defined. And in a similar fashion to the transpiler, there is a template engine that allows me to render the XML structure, basically.
Yep.
So what I did here is I defined the template structure. You know, there's kind of cascading templates here for the device response document. You know, I have data items, components for each of these data items. I've got a separate template. So you can test those. You can see, you know, this is the output that's going to have.
Yep.
Okay, so now let's see what that produces. So now the components are named appropriately. They have their IDs and names. Some of those are not coming through. But yeah, I mean, this is, I think I spent about 5 days between creating the transpiled list of vocabulary, defining these concepts, and then coming up with these templates.
Yep.
And the result is, you know, now I can manage all this visually instead of through XML.
Yeah, it's really fantastic. I mean, so if I want to use this composer, ThinkComposer, should I use the transpiler? I mean, I'm curious how to run the ThinkComposer and associated with the transpiler.
Yeah, so in this case, ThinkComposer it utilizes domain files and composition files. So in order to use this, like everything that you've seen here. I just need to provide you with the definition for my domain. So in this case, I have the MTConnect domain. If I share this with you here, yeah, you would download that, drop it into, after you install ThinkComposer, you should have a My Compositions folder in your documents.
I see.
Yeah, if you just paste that in there, and then when you create a new composition,
Okay.
It lists a bunch of generic domains, but then if you click in the upper right corner, go to the user's documents folder, you should see that mtconnect.tdom. So this template, almost like a Word template, or Microsoft Office template, it will load in all of these concepts and the relationships and the templates for generating the device file. All that should get loaded in.
I see. Well, it's really fantastic. Typically when I develop a MTConnect agent and the MTConnect software, sometimes I had to. So in that case, my work is quite complicated. First, I need to define the Devices.xml, and then to visualize that XML, typically I use the PowerPoint, block to show the structure of the Devices.xml I defined, right? So in that purpose, it's really fantastic. Is there any reverse option, like if I have the Devices.xml
and it generates the visualization?
Generate the visualization.
That's definitely something I've been interested in too, especially since I worked on this. Is that reverse side? So
I think, but I think ThinkComposer is really nice, and of course I like the transpiler concept.
Thank you. Yeah, the ThinkComposer, like I said, it's a bit outdated. It's not maintained, so you're bound to find some bugs. Probably the biggest one is when you go to generate output from these languages. It's you have to go through and like double click on these concepts and then just test each one. And after you test it, I don't know, that kind of opens up some sort of memory buffer to properly generate everything.
Yeah, I guess I can just test the document for the generation without exporting the XML document. But yeah, I really appreciate your time and kindful explanation. It's really awesome and fantastic.
Thank you very much. I appreciate it.
Yeah, I heard a lot from John. Actually, John demonstrated the transpiler, especially the adapter concept. Adapter send information of the device XML.
Yeah.
And then it's really nice.
Yeah, I definitely recommend the SDK because it simplifies development quite a bit. So
yeah.
I think another
good thing to circle back on, because you use Python quite a bit, right? And so
yep.
So we have that kind of in the pipeline as a target to create an additional sink for the transpiler. So that C# library that I showed you, that you can navigate the SysML model through C#. We'd like to do the same thing just in Python.
I see.
So generate these structures and documentation to where you could potentially use IntelliSense using Python.
Yep.
So we also have it for C++ and Java, and then some other projects for different API definitions like JSON, YAML, and Swagger.
Yep, I see. Yep.
Anything else, John?
Nope. Yeah. Thanks for joining us, Eunseob.
Yep, sounds good.
All right.
Yeah, thank you.
Thanks, guys.
Bye, Eunseob. Bye, Trais.
Yep.
See ya.
Bye-bye.